Hello everyone. Today we will discuss trigonometric functions as periodic functions. Periodic function means after a certain period, value repeats. So here in sin x and cos x we will discuss. I'm going to start with this point A, and in anti-clockwise direction when this point A is completing one complete revolution. So at terminal point is A again. So your angle will be 2 pi radian, and after that if this point is moving and reaching at point P, so the angle will be, in sin x we can write it as 2 pi sine of 2 pi plus x, and this value will be equal to sine of x. Similarly, second revolution, then again x, so it will be sine of 4 pi plus x, and this is also equals to sine of x. So because of that, we can write that sin x is a periodic function. After a certain period, value always repeats in trigonometric functions. So in sine, we can see that multiple of 2 pi is there. Similarly, in cos also the same thing. Cos of 2 pi plus x, that will be equals to cos x. Then cos of 4 pi plus x, that will be equals to again cos x, and so on. So we can observe here, if x increases or decreases by any integral multiple of 2 pi, the values of sine and cosine functions do not change, means value always repeats. So we can write sine of 2n pi plus x equals to sine x, where n belongs to integer, and cos of 2n pi plus x equals to cos x, where n belongs to integers. So I'm going to write that sine of 2n pi plus x, that is equals to sine of x, where n belongs to integers, and cos of 2n pi plus x, and this is equals to cos x, where n belongs to integer. This is very important part of trigonometric functions. So here we have discussed always in multiple of 2 pi in sine and cos, value will be same. Now we'll discuss here one more concept. We know that in y coordinate always we get at x-axis y coordinate will be 0 always. At x-axis y coordinate is 0. Here, if I'm taking here a point, if I'm taking a point 2, 0, means always x-axis y coordinate is 0. Ordinate will be 0. We know this one. So here, what is ordinate value? Your ordinate is at the point, according to the point P, ordinate is sine x. So sine x is 0, where at x-axis. So x-axis, right side of this point O and left side also, both sides. So according to that, can we write here sin x equals to 0 when x equals to 0 radian? When x equals to 0 radian, here sin x is 0, because at y coordinate, at x-axis, y coordinate is 0. Now similarly, this is also x-axis, left side of this part, x-axis. So we can write at x equals to pi also, sin x will be 0. Similarly, if we are taking in clockwise direction, the same thing will be happen, means x equals to minus pi also, sine will be 0. Then when x equals to, when we are repeating it, means multiple of pi, so it will be 2 pi, then 3 pi, then 4 pi, then 5 pi, and so on. So x equals to 2 pi, then 3 pi, then 4 pi, and so on. So always sin x will be 0. Similarly, in negative also, when x equals to minus 2 pi, minus 3 pi, minus 4 pi, always sin x will be 0. So we can conclude here sin x equals to 0 when x equals to 0 plus minus pi plus minus 2 pi plus minus 3 pi plus minus 4 pi and so on. So this is also important concept here. So according to that we can write here, so we can conclude here sin x is 0 when x equals to n pi, where n belongs to integers. N pi, where n belongs to integers. Now for cos x, we will discuss. We know that in the y-axis, always x coordinate means abscissa will be 0. If I'm taking a point here in y-axis, so it is here what? 0, 3. So we'll write here in y-axis, always x coordinate 0. So according to that, we can write here x coordinate is here cos x. So cos x equals to 0 where in y axis. So we can write it as, we can conclude that cos x equals to 0 when x equals to y axis means pi by 2. Then after that 3 pi by 2. Then similarly minus pi by 2 minus 3 pi by 2. Then here again we will add pi in pi by 2, that will be 5 pi by 2, then 7 pi by 2, then 9 pi by 2, means odd multiple of pi by 2. So we can write here cos x equals to 0 when x equals to pi by 2, then 3 pi by 2, then 5 pi by 2, 7 pi by 2 and so on, means odd multiple of pi by 2. Similarly in negative also, minus pi by 2, minus 3 pi by 2, minus 5 pi by 2, minus 7 pi by 2 and so on. So we can write it as cos x equals to 0 when x equals to plus minus pi by 2, plus minus 3 pi by 2, then plus minus 5 pi by 2 and so on. So we can conclude here cos x equals to 0 when x equals to, this is odd multiple of pi by 2. 1, 3, 5, odd numbers are there. So according to that, we can set in a system that is 2n plus 1 pi by 2, where n belongs to integers. So these two are very important forms in trigonometry. You have to remember it so that you can solve questions based on that. In sin x is 0 when x belongs to n pi, where n belongs to integers. And cos x is 0 when x equals to 2n plus 1 pi by 2, odd multiple of pi by 2, where n belongs to set of integers. So here we can get some more values based on that. Fx equals to function tan x. Tan x we know that is sin x by cos x. Here cos x should not be 0. If cos x will be 0, then we can get not defined value of tan x. So because of that I have written here cos x not equals to 0. And cos x equals to 0 when x equals to odd multiple of pi by 2, means x should not be equal to 2n plus 1 pi by 2, where n belongs to integers. Then function cot x. Cot x means cos x by sin x. And here sin x not equals to 0. And x will be 0 in sin, that is n pi. So x not equals to n pi, where n belongs to integers. Then in sec x we can write 1 by cos x. Here cos x not equals to 0. Otherwise we will get infinite value or not defined value of sec x. So x not equals to 2n plus 1 pi by 2, where n belongs to integers. And next, that is cosec x, we know that it is 1 by sin x. And sin x not equals to 0, where x not equals to n pi, n belongs to integers. Actually these are beneficial to find domain values of trigonometric functions. We'll discuss that. In class 10th, we have discussed values of trigonometric ratios. It means in terms of degree, 0 degree, 30 degree, then 45 degree, then 60 degree, 90 degree, like that. So here also we'll discuss the same values, but These are called trigonometric function values. So we'll start with 0, pi by 2, then pi by 4, pi by 3, pi by 2, pi, then 3 pi by 2 and 2 pi. Radian form we will discuss here. So we have discussed earlier that sine of 0, that is 0, sine of pi by 6, that is 1 by 2, sine of pi by 4, that is 1 by root 2, sine of pi by 3, that is root 3 by 2, sine of pi by 2, that is 1, then sine of pi, that is 0, sine of 3 pi by 2, that is minus 1, and sine of 2 pi, that is 0. Then cos of 0, that is 1, cos of pi by 6, that is root 3 by 2, cos of pi by 4, that is 1 by root 2, cos of pi by 3, that is 1 by 2, cos of pi by 2, that is 0, cos of pi, that is minus 1, cos of 3 pi by 2, that is 0, and cos of 2 pi, that is 1. So only these two function values you have to remember, except that you can find out. Tan x, we know that tan x is sin x by cos x. So 0 by 1. By using that we can find. So this is 0. Similarly, sin x by cos x. So 1 by 2 divisible by root 3 by 2. So we can get here 1 by root 3. Like that we can find out. So here I'm going to write tan of pi by 3. That is root 3. Then tan of pi by 2, 1 by 0, that is infinity, not a defined value. Then here 0 by minus 1, that is 0. Then tan of 3 pi by 2, that is minus infinity, means infinity, both are similar. And tan of 2 pi, that is 0, 0 by 1. Similarly in cosec, cosec means 1 by sin x. So according to that, I'm going to fill your values. So these are the values of trigonometric functions from 0 to 2 pi. So cosec of pi by 3, that is 2 by root 3, cosec of pi by 2, that is 1, then cosec of pi, that is infinity, then cosec of 3 pi by 2, that is minus 1, and cosec of 2 pi, that is infinity. Sec x is 1 by cos x. So according to that it is 1. Then here sec of pi by 6, that is 2 by root 3. Then sec of pi by 4, that is root 2. Then sec of pi by 3, that is 2. Then sec of pi by 2, that is infinity. Then sec of pi, that is minus 1. And then sec of 3 pi by 2, that is again infinity. And then sec of 2 pi, that is 1. Then cot of 0, that is infinity. Then cot of pi by 6, that is root 3. Then cot of pi by 4, that is 1. And cot of pi by 3, that is 1 by root 3. Then cot of pi by 2, that is 0. Then cot of pi, that is infinity. Cot of 3 pi by 2, that is 0. And cot of 2 pi, that is infinity. We know that some values we have discussed earlier, that tan x equals to infinity when x equals to odd multiple of pi by 2. 2n plus 1 pi by 2. You have to remember it. When n belongs to integers. Similarly, cosec x equals to infinity. So when x equals to n pi, where n belongs to integers. Now next, sec x equals to infinity when x equals to again odd multiple of pi by 2, 2n plus 1 pi by 2, where n belongs to integers. And next, that is cot x equals to infinity when x equals to n pi, where n belongs to integers. So you have to remember this table. This is very important table. Now we'll discuss sign of trigonometric functions. So here I have drawn a unit circle where radius is 1 unit, and I have drawn angles in anti-clockwise direction angle x, and in clockwise direction angle minus x. So according to that, point P is here cos x, sin x, and coordinates of point Q will be here cos of minus x, sin of minus x. Now if you have to find out cos x, so we can write it as, we know that this is base divisible by perpendicular. So this is again 1 unit. Sorry, base divisible by hypotenuse. So it is here OM by OP. Now if you have to find out cos of minus x, means in clockwise direction, this direction, cos of minus x. So here it is OM by OQ, and OQ will be always positive, because we know that this is hypotenuse part, root over p square plus b square. So because of that, it will be always positive. So OM by OQ. So here we are showing signs, means positive, negative signs. So when we are taking cos x, that is positive by positive, and here OM is positive and OQ is also positive, means cos of minus x is equal to cos of x. This concept we are getting from here. Now we'll discuss for sine. Sine of x, we can write it as, this is PM by OP. And this is positive, and again this is here positive. Now sine of minus x, means in clockwise direction for this angle, minus x. So this is here MQ. Here for this right angle triangle, OMQ. According to this right angle triangle, we have to take perpendicular is MQ. MQ divisible by hypotenuse is OQ. So MQ, we can see it is parallel to negative of this y-axis, means downward. So it is negative. MQ is negative. Negative by, and OQ will be always positive, I have told. Positive. So sine we are getting here negative. So we can write here sine of minus x is equal to minus of sine x. Very important concept. These two are. Similarly, by using cos and sine, we can find out tan also. Tan sine, then cosec, sec and cot. Means if we have to find out sine of tan of minus x, we know that this is, we can write it as sine of minus x by cos of minus x. Sine of minus x is minus sine x by cos of minus x is cos x. So we can write it as, this is equals to minus of tan x. So we are getting here tan of minus x equals to minus of tan x. Then we can find out for cosec, sec and cot. So according to that, first of all, we'll find out for cot of minus x. This is, we know that this is equals to, we can write 1 by tan of minus x. And tan of minus x is minus tan x. So 1 by minus tan x. So we can write it as minus cot x. So cot of minus x equals to minus cot x. Then for cos of minus x, we can write it as, for sec of minus x, we will find out this is 1 by cos of minus x. And 1 by cos x it will be, and finally we'll have here sec x. So sec of minus x equals to sec x. Now we'll find out for cosec. Cosec of minus x, we can write it as 1 by sine of minus x. So it is here 1 by minus sine x, and we can write it as minus cosec x. So these are the signs of trigonometric functions. So very easy to remember. For cos and sec, for these two, we are getting positive, and rest we are getting signs of trigonometric functions. So for determining signs of different trigonometric functions, I am considering here a unit circle with center O at the origin O of the coordinate axis. This circle meets the coordinates axis at point A 10, point B 01, point C -10, point D 0, -1. Let us consider a point P, coordinates are AB, be a point on the circle such that length of arc AP equals to x. Let AB, point PAB be the point where the terminal side of the angle AOP with radian measure x meets the unit circle. So according to that, we can write here cos x equals to A for all x belongs to R. Cos x means B by H, base by hypotenuse. So here this is a unit circle. So base is here OM and hypotenuse is OP. So OM is here A and hypotenuse is 1. So according to that, cos x equals to A. Similarly, sin x equals to B for all x belongs to R. Sin, we know that is perpendicular by hypotenuse. So here we have PM by OP. OP is here 1 and PM is B. So B by 1, that is B. Then third one, we will find out tan x. Tan x is sin x by cos x. So we can write it as B by A. B by A for all x not equals to 2n plus 1 pi by 2, where n belongs to integers. Odd multiple of pi by 2 will not take, otherwise cos will be infinity. The cos will be 0. So tan will be infinity. So here tan x equals to B by A. Now next one, cot x. Cot x we can write as cos x by sin x. So this is A by B for all x not equals to n pi, where n belongs to integers. And then sec x. Sec x we can write as 1 by cos x. And 1 by cos x is A. So 1 by A for all x not equals to 2n plus 1 pi by 2, where n belongs to integers. And last one, that is cosec. Cosec x we can write as 1 by sin x, and sin x we have considered as B, so 1 by B for all x not equals to n pi, where n belongs to integers. Now we'll find out signs in different quadrants. First quadrant, second quadrant, third quadrant and fourth quadrant. We know that angle x greater than 0 and less than pi by 2, that is first quadrant. This is the second quadrant, in between pi and pi by 2. Third quadrant, in between pi and 3 pi by 2, and fourth quadrant in between 3 pi by 2 and 2 pi. Here we observe that point PAB moves on the unit circle, and point M moves between C and A, and N moves between D and B. So according to that, we can write here, in the first quadrant, A is greater than 0, B is greater than 0. In the second quadrant, A is less than 0, B is greater than 0. In the third quadrant, A is less than 0, B is less than 0. In the fourth quadrant, A is greater than 0 and B is less than 0. So here A is greater than 0, B is greater than 0 in the first quadrant. Then in the second quadrant, A is less than 0, B is greater than 0. In the third quadrant, A is less than 0, B is less than 0. And in the fourth quadrant, A is greater than 0, B is less than 0. So we'll discuss signs. So first quadrant means in between 0 and pi by 2. Here this part, in between 0 and pi by 2. This is the first quadrant. So here A is greater than 0 and B is greater than 0. Both positive. A is greater than 0 and B is also greater than 0 in the first quadrant. So here cos x will be also greater than 0 and sin x will be also greater than 0. If cos and sin both will be greater than 0, then tan will be also greater than 0, and then cot will be also greater than 0, sec and cosec also greater than 0. So we can write here tan x equals to b by a, that is also greater than 0. Then cot x equals to a by b, that is greater than 0. Then sec x equals to 1 by a, that is greater than 0. And then cosec x equals to 1 by b, that is also greater than 0. Means in the first quadrant, all positive. All trigonometric functions are positive. Now second quadrant. In the second quadrant, a is less than 0, b is greater than 0. Second quadrant means in between pi by 2 to pi. This is the second quadrant part. So here a is less than 0 and b is greater than 0. So according to that, cos x is a, that is less than 0. Means negative. And sin x is b, that is greater than 0, means positive. It is negative and it is positive. Then tan x we will find out. Tan x is b by a. So positive by negative. So it will be negative. Means tan x is less than 0. Then cot x also less than 0. Then sec x is 1 by a, and a is here less than 0. So according to that, cos x is also less than, sec x is also less than 0. And then cosec x, that is 1 by b. b is greater than 0, so this is greater than 0. Means in the second quadrant, conclusion is sine and cosec positive and cos, sec, tan and cot negative in the second quadrant. Now we'll proceed to third quadrant. Third quadrant, a is less than 0, b is less than 0. Third quadrant means greater than pi and less than 3 pi by 2. So a is less than 0 and b is also less than 0 in the third quadrant. So according to that, we can write here cos x equals to a, that is less than 0. Then sin x equals to b, that is less than 0. Then tan x equals to a by b. Sorry, b by a. b by a. So negative by negative, that will be positive. So tan x will be greater than 0. And then cot x also a by b, that will be greater than 0. Then sec x, that is 1 by a, that is less than 0. And cosec x, that will be 1 by b less than 0. Means in the third quadrant, tan x and cot x positive, sin x, cosec x, cos x and sec x, these are negative in the third quadrant. Now next we will discuss for fourth quadrant. Fourth quadrant means in between 3 pi by 2 and 2 pi. So here a is greater than 0 and b is less than 0. A is greater than 0, b is less than 0. This is the fourth quadrant. Greater than 3 pi by 2 and less than 2 pi. So here we will discuss signs of trigonometric functions. So cos x, that is a. A is greater than 0 means positive. Then sec x will also be positive. Then sin x. Sin x is b, less than 0. So this is negative. Then cosec x will also be negative. Then tan x, that is b by a, negative by positive, that will be negative, less than 0. And then cot x, that is a by b, positive by negative, that will be also less than 0. So in the fourth quadrant, we can get here in the fourth quadrant cos x and sec x positive, sin x, cosec x, tan x, cot x, all negative. So here I have drawn first quadrant all positive, second quadrant sin and cosec positive, cos, sec, tan and cot all negative, rest negative. Third quadrant tan x, cot x positive, then sin x, cosec x, cos x and sec x negative, and the fourth quadrant cos x, sec x positive, sin x, cosec x, tan x and cot x negative. Now we have to remember it. Very easy way to remember. I'm giving here a phrase. That phrase is all school to college. By using this phrase, you can remember it. Signs of trigonometric functions, different quadrants. The first letter of the first word in this phrase is A. A represents all, means first quadrant, all positive. Now next here, in the second word is school. In the school, S, starting with S. So S indicates sign and its reciprocal positive, means sin and cosec positive, and rest negative. Third, that is 2. By T we can use tan and its reciprocal positive, tan and cot. And by the fourth word starting with C, we can represent cos x and its reciprocal sec x positive and rest negative. So by using this phrase, we can remember signs of trigonometric functions in different quadrants easily. First quadrant, then this is second quadrant, this is third quadrant, and this is fourth quadrant.